Alright, so number one is to balance the equation. So most of the homework, they'll give you balanced equations already, but if they say unbalanced, you're going to have to balance some equations in the homework. Two is a thing called the limiting reagent. I'll explain that once you have your own paper back to you, what exactly we're hunting there. Three is a thing called the excess reagent. Four is a theoretical yield. Five is an actual yield. 6 is the actual yield again, or you could have just circled number 5 because number 5 is always the bigger of the two. 7 is a percent yield, and I'll pause there. Does anybody need me to rerun back through any of those new words, what they were supposed to be? Okay. Then we have our redone from yesterday words. So there's stoichiometry as a word. You don't have to spell that perfectly, but if it's a mess, give them half a point. It's S-T-O-I for the stoi, C-H-I for the key, ometry, O-M-E-T-R-Y. So messy stuff, go half for a day. Definition on that, it's the measurement of the relative quantities of reactants and products in a reaction. So words we'd be hunting would be measurement. So if you don't see the word measurement, you're out at least a half. Relative quantities is a phrase we're hunting. If they just said quantities, I can live with that. But if you just had relatives, quantities is a word you really do need. Reactants and products should appear in there. Reaction should appear in there. So if you're short like a word or two, I could go half. But if you're short like 3, 4, or 5 of those 5 words, you do not have a right answer. So look for measurement, look for quantities, look for reactants, look for products, look for reaction, form a sentence around it. 6 to 10 is wrong numbers. 10 to 14 is reactants and products, molecules of each, moles of each, relative masses of each. If you just have masses of each, I can go with that. Volume of gases is in there. 15 is mole. 16 to 18 is calculate or find some sort of verb. Find the moles of known, find the moles of unknown, and then find the mass or the volume of the unknown. Then the last 3 is mass, volume, or do it backwards, and volume, and that's our day today to 21. Anybody need a rewind to 21 or some sort of judgment on whether I think what you're reading is correct or incorrect? So back to owners, and then let me fill in the blanks with where we go next. There's not a quiz tomorrow, there's not a reading tomorrow. What there is for tomorrow is a homework based on the math that's behind me that stretches from 3 to 22. Since that is your only responsibility, I will require you to do at least 5. 3, 4, 5, 6, 7. If you show up and you haven't done the 3 to 7 part of 3 to 22, I'm going to shut you out forever from ever getting points for that homework. So 3, 4, 5, 6, 7 at minimum. Keep working. Ultimately, we're 3 to 22, but that is your only job for tomorrow is to do that homework. So that needs to have something happen. 10.5 is the next read, so I'll just describe that today while we're on topic from 10.4, but the next quiz you have is 2 days out. So 2 days from now, 10.5 quiz, there's 3 new points of reading from 10.5, and I say new points loosely because these are not new points to chemistry, they're just new points to chapter 10 quizzes. There's going to be a couple familiar things that you've heard of before. Relative to other things, the quiz today from 8 down, it just is what it's always going to be. So that'll be an exact repeat from today's 8 down. It just is what it is. And then the top is where I need to explain some things to you to make some sense of what this is about. So 1 stays the same, that you'll need to balance equations if they're unbalanced. 2 goes backward. So I'll ask you what a limiting reagent is. So you would say it's a reactant that is completely used up. It's basically something you're going to run out of. I don't know if you have cookie baking experiences in your household like we have cookie baking experiences in our household. But pretty much every time we go to bake cookies, we realize we're going to run out of something and probably don't have enough to do it, and have these conversations like, who used all this sugar? Why is there only one egg? Why didn't anybody say anything about the flour? Like, we just don't have always enough stuff to do baking projects in our household. Maybe your household is better organized than mine, I don't know. But the limiting reagent is the thing that you'd run out of. You know, you go to bake cookies and you have one egg. The egg is your limiting reagent. You're going to run out of it. You don't have enough to go relative to your other ingredients. Well, 2 will go backward. What is a limiting reagent? 3 will go backward. What is an excess reagent? It's a reactant that's not completely used up. So it's the stuff you're not going to run out of, and you're going to have some leftovers on that. Theoretical yield for number 4 goes backward. It's the amount of product you expect. 22, or it'll be 22 tomorrow. Today's number 5. Actual yield goes backward. It's the amount that you obtain. I'll ask you again, just like I did today, which one's less, and it's the actual yield, and I'll come back with why. Does anybody from reading comprehension superpowers have a reason why the actual is less than the theoretical all the time?
You're finding the percent of the theoretical that it actually happens, so the theoretical is bigger than what actually happens.
That's true, but why? Like, what happens during the experiment? Stuff happens and it never goes to plan. There's always like issues. Can anybody explain what one type of issue might be you'd run into? It's a good thing I'm here. So I've got 4 items going on here. So just jot these all down. If you want the full point, just fire all 4 back next time there's a quiz. 1 is side reactions. So side reactions is basically, while you're having the main reaction happen, other things might react and do things. So that's a side reaction. Isolation was a thing. Isolation basically means you just maybe can't get at it. If we go back to our cookie example, did you ever try to get like the last bit of flour out of the jar? It's not that easy sometimes. Like, you just can't like get in there. Purification is a choice. Purification meaning things aren't pure. Like, there's impurities in your stuff, and maybe that causes you not to get what you expected. And then the last thing is transferring from container to container. You know, I drank a water before you guys came in. If I pulled the bottle out, there's still all sorts of water in that bottle. I didn't get every last drop of water. I think you're familiar with the idea that most containers, there's like a little bit of left behind stuff. So the actual is less than the theoretical because of those things. Side reactions, isolation, purification, transferring from containers to containers. Then there's going to be a math question that's number 7, just in reverse. I'll ask you how you figure out the percent yield, and it's just a basic percent move. It's the actual divided by the theoretical times 100. Actual divided by theoretical times 100. So quiz popped slightly up to 25 from 21 because there were 3 new ones in the reading, and then something became, the why question. Which is less for number 6 gained a Y on it. Question about what the quiz contains. Well, here's the math around your life. If you want to join me, I'm just working the book examples straight out of the book. So I'm starting on 251, and I'm just going to run through these. So if you join me on 251, that's probably helpful for you to understand what's going on a little bit. But off we go. Example 10.1, they give you an equation, and good news, it's already balanced. Hooray! So they tell you in the problem there's 72.0 grams of C2H6. So I started to do some dimensional analysis already, just to make sure we understand this. Whatever they give you goes in the next slot, bottom, because it's like fraction multiplication. Tops and bottoms can cancel. So we like that. So we're going to turn grams into what? What was our thing on the quiz? What are the steps? You first find moles of what you know. So they're going to give you grams of something, probably, and you're going to want to turn grams into moles. The magic number for moles is always 1. How do you get gram numbers?
Periodic table.
Periodic table. So we did C2H6 yesterday. It was 30, and it hasn't changed since then. 2 12s plus 6 1s would get 30. That's your first move, is figure out the moles of what you know. So I'd say most of the time, they'll give you grams. So most of the time, we're going to need a gram number here from the table. I would make you show work, because if you're not writing down how many grams you had in your mole, it's impossible for us to communicate tomorrow when you say, I didn't get this right. And I'm like, well, how many grams did you think there were in C2H6? And you say, I don't know. Well, that doesn't help us. Question about that? Okay, then what's plan B? Find the moles of known. Then find the moles of unknown. So we're going to need to go from moles of what we know to moles of what we want to know. They could ask us about H2O. They could ask us about CO2. They could ask us about O2. We'll have to look at the book and see. They want us to find grams of oxygen. So we need to go moles of O2. When you do the mole-to-mole conversions, and I think this is what makes this chapter new to your life. I don't think you've done this. The mole-to-mole conversions, where are you going to grab those numbers? They're hiding in plain sight.
Some scripts on the...
No. Mole O2 number?
Is it the
It's the coefficients. This 7 with the O2 tells you that there are 7 moles of O2 compared to C2H6 has 2 moles. Those are going to get used, I think, in every problem. Not every problem will have grams. I do think every problem is going to use those coefficients. That's why we're in this chapter. So moles of the old stuff is out. Moles of new stuff is in. If they ask you to find moles, you'd be done. And sometimes they do. Sometimes these problems stop at that point. But here they want you to get from moles of oxygen to grams of oxygen. So moles of O2, that number is going to be pretty much always 1, unless you're working from mole-to-mole conversions. And we want grams of O2. What would be the magic number for grams? 32. Because oxygen is 16, there's 2 of them, so we use a 32. If you want to push buttons to check your button pushing skills or to double check my math skills, we're hoping that turns out to be 269, but I feel pretty sure we're good. If you don't want that button push a minute, go for it. Anybody not follow, what happened? That's as big as they're going to get. Well, that's a lie. It's close to as big as they're going to get. There will be some shorter than that, but this is on the outer edge toward how long the dimensional analysis goes. How could they make your life easier than starting you with grams? Starting with moles. They will do that. How could they make life easier than ending with grams? End with moles. So sometimes we can shave a step at either end if they involve moles more quickly. Question about what happened there? So much fun. Let's do it again. So example 10.2, they give you an equation, and good news, it's balanced. They tell you 22.1 grams of the manganese stuff. So I already started my slot here with 22.1 grams of manganese stuff. So my first move is getting rid of grams of manganese. And we need to turn everything from whatever it is into moles. Gram to mole, the number's always going to be 1. MnO2, you're probably willing to just take my word for it. If we do the math from the periodic table, that's going to turn out to be an 87. If you don't know how to get the 87 from the table, I'll explain it. Does anybody need me to explain how I could get an 87 from that from the table? Okay. So O we know is 16 times 2 is 32. And we'd have to look up the Mn. Mn must be 55. Anybody have a table handy? Is Mn 55? So we're going to take the 32 plus the 55, gets you the 87. Is that okay? So that's going to be your first move. You have to get to moles. If they don't give you moles, you have to get the moles of what they had. Use the periodic table. Then what's the next step? After you know the moles of the known, get to moles of unknown. So we need to trade moles of MnO2 for moles of something else. And we'll have to read the question to see what they want, because there's 5 things to choose from. They want us to find stuff with chlorine. So moles of the Cl2. What's the number for moles of Cl2?
Is it just one again?
It is just 1, because that didn't have a coefficient. Moles of MnO2,
Just one again.
also 1, because that didn't have a coefficient. So we have those 1. So if you forgot to do that step this time, you'd be okay. Got lucky. I wouldn't count on that. There's usually a mole-to-mole conversion where you have to use those coefficients, and that usually is very important. Moles are out of the old thing, moles are in of the new thing. And then we see, do they want more? Probably yes. They want grams of that. So we need to get from moles Cl2 to grams Cl2. When we go mole to gram, the mole number will always be 1. When you go mole to mole, you're using the numbers from the equation, the coefficients. But mole to gram, it's going to be 1. Cl, is it like 35.5? Yeah, so 2 of those would be a 71. Push a bunch of buttons. If you want to push buttons to make sure you're pushing the right buttons, I'm thinking that it's going to turn out to be 18. 3 sig figs go 18.0 grams. I'll be picky about units on this. Like when we get to the test, this would need to be 18.0 and then have all of that grams of Cl2. Yes, sir.
I know that.
Sure.
What did the 18 from?
Push a bunch of buttons. So the 22 divides the 87, multiplies the 71, just punch it all in. You multiply every number on top, divide by every number on the bottom. Ignore the ones if you want to.
Just dimensional analysis.
Yep.
I just didn't know.
Yep. Something there? 10.3 says, here's an equation and then bad news. Unbalanced. So if it's unbalanced, the quiz forewarned us we were going to have to balance things. So what do you want to do first? Yeah, the O's are out of whack. So the quick skim, the K's and the CL's are already pretty good, but the O's are out of whack. So if this has 2 and this has 3, the only way to balance that is multiply 2's group by 3, while you multiply 3's group by 2. When you did that, now you messed up the K's and the CL's, so if you chase them down, they needed 2. Question about balancing? So then we go at it. They give you grams of KClO3. So grams go out and in come moles. When it's gram mole, the mole number is 1. The gram number, you're going to have to go periodic table. So I have it on my paper as 122.6. Or we can math that out if we need to. But you'd have to go 3 times O's number, which is 16. Add CL's number, which we just said was 35.5. Add K, which I think is 39.1, but I don't maybe remember all of these from last time I did it. But we'd add up all that math, we'd get a 122.6 there. Anybody question about that? Then moles unknown goes out, and in comes moles of unknown. And we're going to have to skim to see what they're hunting. They're hunting oxygen. When we go mole to mole, the numbers might be 1s, they might not be 1s, who knows? Where are we going to get the numbers for mole to mole? Coefficients. So O2, we had a 3, KClO3 had a 2, and then we hope they want moles because then we are done. But if they want grams, we're going to have to use periodic table again. So we check what it says. It says find the number of moles, so we're good. We just push some buttons, multiply all the tops, divide all the bottoms. If you want to push buttons to verify that we did the right thing, it would be a 0.0202 moles of O2. If it's a test, I'd want you to say moles O2, get me that number, 0.0202 moles O2. Something about that. Could you reposition that down the line for my next call? Thank you.
Wait, down there?
Yeah, just like, I
Oh.
don't need this. If you just move it to the other side of you, it should be okay. Or,
Yeah.
thank you. 10.4 says use the same equation. So we already did that equation, we're going to use that again. Why are we happy about 0.105 moles KClO3 being given to us? It takes out a step. And it takes out the step you probably like the least. Okay, you probably like the least breaking out your periodic table and adding up all those numbers. So if they give you moles to begin with, we cut that step. So we're starting with already moles of known, so we're ready to convert that to moles of unknown. So moles of what we know goes out, moles of what we're hunting comes in, and we are hunting O2 again. So how do we do the mole-to-mole numbers? Coefficients. So O2's number was 3, KClO3 was 2, and then you hope, oh please, just ask me for moles, but you're usually not that lucky. If they asked you for moles, you'd be done. But no, they say grams, so we've got another step to go. So we need moles of O2 out, grams of O2 in, mole to gram conversions, mole number is always 1. Gram O2? 32, because 2 times 16 is 32. Math it up. Again, if it's a test, I'd want you to say grams O2 is your unit. The number here we're hunting is 5.04. Something about that. 10.5 is the best problem of all because they start you with moles and they ask you for moles. So that's going to be a good deal. They start you with moles of Na. They want you to find the moles on this one of H2. So all you need to use is numbers, grab some coefficients. So H2 be a 1, Na 2, math it up. On a test, I'd want you to say moles O2 for your unit. It'll be for the numbers of 0.075. Something about first 5. That's where the homework's going to start. So when you do this homework, and again, I'm demanding 3 to 7 at least to get you started, you should actually be fairly comfortable of that difficulty level blend, probably to like 18. I don't think 3 to 18 has anything bigger than where we came in. Okay? 3 to 18 is just going to flow how those flow. Some are longer, some are shorter, but the mix we did, it should take you 3 to 18. 19 will be different. And that's why a minute ago I said this was the longest one you'd see, and then I quickly retracted it because it's not true. Question up to there. This one I think I'll have time to carry it all the way through. There's a couple more examples that I'll have to spill to tomorrow. I'll have another example like this tomorrow. But 10.6 is a limiting reagent problem. Limiting reagent problems you're going to know because even if they don't label them, they're going to give you 2 amounts of stuff. One of the amounts of stuff is going to have what happen to it? Run all the way out. And the other one's going to have some leftovers. And there's no way to know until you do double math which is which. Okay, so the limiting reagent problems, they're going to give you 2 startup quantities. You're going to have to do the math we've been doing and then figure out eventually who ran out and who's left. And they're also going to want to know how much is left once you figure out who ran out. But for this example 10.6, even if they didn't label it limiting reagent problem, you know it is one because they gave you two things. They gave you 50 grams of CaCO3, which is in the equation. They gave you 35 grams of H3PO4, which is in the equation. And one of those is going to run out, one of those is going to stay. So we're going to need to basically do double of what we've been doing. Question about the concept? So first thing, as always, if we're given grams, grams turn into moles. The number for moles continues to be 1. CaCO3 would involve 40-ish, I think, adding 12, adding 3/16, add. I'm just going to cheat off my paper, and this is 100.1. Once we have moles of one thing, we're going to turn moles of one thing into moles of another. The thing that we're hunting in this problem 10.6, we're hunting calcium phosphate. So we're hunting that. Again, for the millionth time today, how do we get mole-to-mole conversions? Coefficients. So the Ca3PO4 is a 1, the CaCO3 is a 3, and then I'll pause there before we push some buttons. Question about what we did there. Okay, I'm going to say do this a little differently. Take the 50, divide by the 100, and jot down that at this point it's 0.500. That's not our immediate need right now, but we will need that number later. How do you know that? Because I said so. How do I know that? Because I've done this before. Okay, but just start off to the mole point, do this, divide this, and jot it down. We will need that at some point in our life. Then divide by the 3, and we have a 0.167. We're going to need that now-ish. We'll need the 0.500 later-ish. Question about the punch-in part? So let's do the other one, same way. We've got grams. Grams turn into moles. 1 is the number for moles. H is 1 times 3. P is like 32 or something. No, sulfur's 32. Phosphorus, it's phosphorus, I don't remember. 31. 4 oxygens is 4/16. You add all that stuff up, and you're going to get 98. Not the worst idea in the world to write down somewhere for homework purposes H3PO4 is 98, because H3PO4 is always going to be 98. Okay, so if you do some of these and then they start repeating them, you can like copy off your own homework in a sense. Like H3PO4 is never going to be anything other than 98. But then we need to get from moles of one to moles of the other. So I need to get to moles of this calcium phosphate thing. Again, for the 1,000,001 time today, mole to mole, always using the coefficients. So this calcium phosphate was a 1, H3PO4 is a 2, and then do the same punch-ins. Do 35 just divided by the 98 and jot it down. Even though we don't need it now, we will need a 0.357 at some point in this process. 0.179 is what you're going to get if you continue to divide by 2, and that's a number, we need to look at these now. Question about the double math? Do you think this is limiting or excess?
Excess.
Limiting. Why would that one be the limiting?
Because it's small.
It made less stuff. This amount of grams is capable of making this amount of moles. This other amount of grams was capable of making this other amount of moles. This is higher, so this is the excess. Question about where we are? This we would now need to finish, and I ran out of board space. They didn't ask us for moles, they asked us for grams. So I would need to go one more step here and turn moles into grams by using table. The periodic table number for this is 310, but the bell's about to ring, so I'll just have to cut that short. So if we took this times a 310, we'd show up at 51.8 grams. This one's not quite done. We'll need to pick that up next time, so we'll re-record a little bit of an ending to this tomorrow, but that's all I have time to do. You're not going to encounter a homework problem like that until 19, and I'm only demanding that you work to 7. So you're not going to see anything like that yet. If you didn't completely get that yet, we didn't even completely finish the problem yet, that's okay. No quiz tomorrow, just homework. 3 to 22, at least get to 7.
Action.
So picking up where we were yesterday, we had just finished the gram part of the problem. And I didn't do something yesterday because I was pressed for time. But whenever we figured out this was the limiting reagent, I like to write limiting as far as the eye can see. So this limiting thing came from CaCO3. So it's not the worst idea to write everywhere you see CaCO3, just write that it was the limiting one. Likewise with the excess, it's not the worst thing in the world to write that these are the excesses. Excess, excess, limiting, limiting, as far as the eye can see. Then I have good news and bad news for you. So what do you like better, good news or bad news first? Bad news. The bad news is at this point we have answered one answer out of 3 answers. Okay, these questions always have 3 answers to answer. We have done the math to answer one of those questions when we finish punching the grams here. So if you did this, divide this, times that, you got grams, you've got 1 answer out of 3 answers, that's your bad news. The good news is, you've done about 80% of the math. Okay, so you got 1 answer, that's the bad news. The good news is, about 80% of the math is done. Okay, but we're gonna have to go back and answer a couple more math questions. So the first question they're going to ask you is how much of the excess is left over. Okay, so the way we're going to do this is figure out how many moles of the limiting did we have. And so that's why yesterday I circled this and wrote it down, because I said we would need that later. Later is now. We have 0.500 moles at this phase of the limiting, and that's one of the reasons why I wrote limiting as far as the eye can see, because when I need to scope out the moles of limiting, I need to find that number somehow, and there's a lot of mess written here. Okay, but there is 0.500 moles of the limiting reagent. I need to turn that with dimensional analysis, moles of limiting into moles of excess. How do we do the mole-to-mole conversions? Coefficients. And that's why on the equation I wrote limiting and excess. Everywhere I could, I wrote that. The number for moles of excess is the 2. The number for moles of limiting is the 3. And I'm going to do that little math step. If I punch this in, it's going to be 0.333 moles of excess. That's how much got used up. Let me pause and just see if we lost anybody. Every time you're going to want to do this. Why? Because I said so. How do I know? Because I did this before. Okay, but you're going to take the moles of limiting that you wrote down somewhere, and then do a mole-to-mole conversion to get yourself the moles of excess. That's just the way you need to do it. Anybody confused about how I got the 0.333 moles that got used? And so we have about 10% more math to do. We need to figure out the moles that are left. There's 0.33 moles of the excess that got used. How are you going to figure out the moles that are left?
2 minus that.
No. Something minus that, but not 2 minus that. How many moles of excess were there?
2.
There's a number I'd said we were going to use, and we haven't used it yet.
It's the,
Like a 1 gram.
357. There were 0.357 moles of excess at the beginning of this problem. So we take the 0.357 moles of excess minus a 0.333 that got used, and there would be 0.024 moles of excess that are left. And now we have like 5% more math to do to get the third answer. Question about where that one came from.
So, if H3PO4 is the excess, and in the problem it says the coefficient is 2, and that means moles. Like, how's that moles? Also, 0.357 is the moles.
Where did we get 1.357?
We had 35 grams in the lab of H3PO4, and we divided with dimensional analysis the grams from the periodic table of H3PO4. In the lab, we have 0.357 moles of H3PO4. 0.333 of those moles got used. But this could have been literally any number in the world. I could have had 20 kilograms of H3PO4 in my well-stocked lab. And I could have had thousands and thousands of moles of H3PO4. But I'd still subtract the 0.333 that got used because this 50 grams of CaCO3 controlled the whole operation. If I did have 3 moles of CaCO3, I would have used 2 moles of H3PO4. But I didn't have either of those amounts. I had 0.5 moles of this, and I had 0.357 moles of that, and we had to figure out who was going to run out and who was going to live.
So, the chemical equation just gives like the ratio.
It gave us a 2 to 3, so that here I could use the 2 to 3, and the limiting number create a used up number so that I could subtract it. Does that make sense? Is that along the lines of what you were asking too? Question about that? Then I probably need my camera assistant to slightly turn me to the left. The third question they'll pop you is, if you actually got 48.7, what percent yield is that? So yesterday I hadn't looked up the number. I told you you could punch it in if you cared. If yesterday you had cared and you punched it in, we would have gotten 51.8. So do the percent yield. It's a 48.7 that they're telling us now they really got. Divide by a 51.8 that the finished calculation yesterday that we hit right at the buzzer would have gotten us, times 100. This is a 94.0% yield. That's our third question. It takes you like 5% of the math to do that. It takes you like 15% of the math to figure out who got left out. It takes you like 80% of the math just to get that first answer. That's the big hump. Question about that process? I'll say this. If that explanation is enough for you to be confident in correctly doing a limiting reagent problem on your own, you are a special human being. You are gifted in chemistry. You should be happy with yourself. If you're like, I don't know that I could do that again by myself, you are a normal human being, okay? But if that was enough, especially getting interrupted in the middle, for you to think, I could do that, you are a special human being, okay? Be proud of yourself. You've been gifted. Thank God for your gifts. We need to do another one of those, because that's like, that's tough.
Now. His head is so big now.
It's the truth. It's hard. That's a hard problem. It might also be false confidence. I mean, maybe he shouldn't be proud till he did one. We'll see.
Give him one, run it.
So here we go. We're just at it again. Here's good news on this too, I guess, is they're all the same. So if you do get to a point that you're like, I understood that limiting reagent problem, guess what? You got it. Like, there's not variety of these. They just are what they are, but they're big. So example 10.8, I'm up to 257 now. So if I weren't telling you this was a limiting reagent problem, how do you know it is one?
There's 2 like
There's two amounts. So in this story, they give us an equation, and we're grateful because they did something they don't always do, which is balance it, so we're happy about that. Then it says there's 20.2 grams CaCO3. So we're always going to turn grams into moles. The number for moles is always 1. The number for grams, get it from the periodic table. Probably willing to trust me, it is 100.1. And we actually had that a second ago. So I stand by a thing I said yesterday. When you figure out the mass of CaCO3, you might want to write that down somewhere. Because you might have to figure out the mass of CaCO3 again in your lifetime. So like, why do that from scratch every time? Maybe build an archive of those. Some of them you'll accidentally memorize if you pay enough attention. Like I think you know by now oxygen is 16. You know that, I don't know, carbon is 12. Who's 14? Nitrogen. So some of them you memorize by accident. Some of them, if you see them enough times and you just pay attention, you might accidentally memorize them, but I'm not asking you to do that. Then we turn the moles of unknown. I always say that backward. Moles of known, I need to turn into moles of unknown. This question, we're chasing CaCl2s. So CaCl2's number is 1. CaCO3's number is 1. It's possible I might need to do another step of math to finish this, but I'm not going to do it now. Why? I might not need it. I might need to finish this one. I'll decide that later. Okay? So maybe another step to come on one of them for sure, but I don't know which one, because one of them's the limiting and the other's the excess, and I don't know who's who for a while, so I'm just going to stop with that. Likewise here, grams turns into moles. Mole number is 1. HCl, probably willing to take my word for it, it's 36.5. Here I'm going to get rid of moles of HCl to create moles of CaCl2. We already decided that was a 1. HCl's number 2.
I swear that was a 3, I don't know why.
That's not unlike what you did on 3, 4, 5, 6, 7 or anything else you tried last night. You did a bunch of problems that far. Question about how I'm creating that, that's like sort of standard operation. What's weird about these is there's 2 of them. And I'm going to do some partial math. So what's a math thing that I want to do? 20 divided by 100, I'm going to punch just that piece, and that is a .202, and I'm going to circle that because I'm going to need that later. While I'm on that line, I'd also do the 1-to-1 thing, and I would get another .202. I'm not going to circle that, I don't care about that later. Like yesterday I did, but not necessary. I know I need to hunt that later, I know I've got a mess, I'm going to circle it partially. Question about that?
So, why, okay, so why are the numbers the same? Well, I know why the numbers are
Because of the 1-to-1.
Okay, yeah.
If these weren't 1-1, I'd say 80% of the problems, you'll get something other than 1s and the number would change.
Okay. So it's,
This is just a lucky break. 1s are nice. Something there in that math. So over here, what partial math do I want? 13 divided 36. I'm going to circle that because I'm going to need that later. That's .362 moles. But I need to keep working, and this would be a .181. And I am going to erase this to make a little bit of space. What do these tell me? 181 is limiting. 181 had to do with HCl. I see an HCl up there, so I'm going to go crazy and just write limiting on everybody. This is then excess So CaCO3 is excess. I'm gonna just go crazy and write excess on everybody so I can find stuff later when I need it. I told you a minute ago, one of these needed finished. Which one is the one we're gonna finish? The bottom one. The limiting problem is the one that we're gonna finish. We're gonna turn moles back into grams. So CaCl2, CaCl2, that's always a 1. Probably willing to take my word for it that this is 111.1. Question about where I am. And then push a million buttons. So if this were still showing on your screen, I guess you could divide by 2 and multiply that again if you want to. Or no, we had already divided by 2. If this is still showing on your screen, just multiply the 111. But this is going to be 20.1 grams CaCl2. One answer out of 3. Did about 80% of the math though. Question about that. That is periodic table stuff. Anytime we're finding grams, we're grabbing our periodic table. So we would need calcium's number, which I believe is 40 and some change, 40.1 I think. We would take chlorine's number, which I think is 35.5, times 2. So 35.5 times 2 adds to 40.1, should make that. I don't guarantee you my periodic table numbers, but I'm pretty sure about those. That makes sense where it came from. Anybody else trouble with the 20.1? So now we have to figure out who's left, what the leftovers are. So we're always going to start with moles of limiting. Eliminate that to get moles of excess. It's always going to be a computation that looks like that. It's just a question of what the numbers are going to be. Somewhere on my board, there is the mole limiting number. Where is my mole limiting number? 0.362. The mole limiting number is always one of these 2 that I circled, and that's why I wrote limiting somewhere. So I'm going to grab that for my mole limiting number. Question about that.
Okay, so you get that number by dividing the 13 by the 30.
Yeah, so 13 divided 36 to create that number.
Yeah, and then you get
And then later down the line, I eventually figured out that was the limiting part of the problem.
So you do half of it and then you do the full thing to get it.
Here I had half of it because of this 1 to 2 thing.
Yeah.
But now what I need is the mole count, which is back here. Something there. Mole to mole, where do I grab mole to mole numbers from my board? The equation. So I need to look for these coefficients. The excess had a 1. The limiting had a 2. So this tells me there's 0.181 moles that got used. I need to know the moles left. Good question about the moles used. That's the excess stuff. We converted to excess. So there's 0.181 moles of excess that are gone. How many moles of excess did we originally start with? 0.202. We started with 0.202. We used up 0.181, so to figure out who's left, you just have to subtract. We're just going to go the 202 minus the 181, and that's 0.021 moles of excess. So there's answer number 2. Again, this answer took about 80% of our labor and time and math and space and writing. That took another maybe 15% of our effort. Something about that. And then here's our last 5% of effort. They'll usually ask you a final question of, they didn't even do it this time. Wait. No, there it is. They say, we actually obtained 18.3. What is our percent yield? So you take the 18.3 you really got, divided by the 20.1 that the prediction was made, And then to make things percentages, it's always times 100. And then the answer on that is 91.0%. Hopefully that feels better for two reasons. One, I did it uninterrupted, which is helpful. And two, it's the second time you saw the process. So if you're feeling better about that than you did 5 to 10 minutes ago, that's good. If you still don't feel great about it, all that means is you're a normal human still. Like if you feel great about that, you're still a relatively exceptional human, I think. The only time you can feel confident in this is you do a couple of your own, eventually over time. But homework, we're working 3 to 22. The limiting problems, if you want to prove that you're an exceptional human being, 19, 20, 21, 22 are all the limiting problems. So if you want to do some showing off and make sure you truly, truly get this, you could go there and try one of those. If you're not feeling it yet, that's why they didn't put those till 19 to 22. Like, get good at the stuff to 18 before you start trying to take on 19. Like, if you're getting everything wrong, 3 to 18, 19 is not where you want to worry about. You want to worry about 3 to 18. Test is going to have a bunch of questions that are like single-sized. It probably has like 1 or 2 of the limiting questions. So they do make the test, but it's a small portion of the test. Question anybody about any of that?